Okay, hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8, belongs to 4th semester B.sc physics or on syllabus CBCS model. In our last class we have been discussed this question: finding the Lorentz series of 1 by z about z0 or z equal to 0. Find the Lorentz series of 1 by z minus 1 about z equal to 1. Step by step we have been discussed these two numericals. Here any one of the numerical if we are going to consider, here in the question it has been asked that we have to find out the Lorentz series about its singular point. Considering 1 by z is the function, here in the question it has been asked that we have to find out the Lorentz series about z equal to 0. Here z equal to 0, it's a singular point, and the Lorentz series about the singular point of this function is itself we found is itself equal to 1 by z. At last we found. Similarly, Lorentz series of 1 by z minus 1 about z equal to 1 also we found itself. That means 1 by z minus 1. Here the Lorentz series of 1 by z minus 1 about it's a singular point or about z equal to 1, we found this one. Lorentz series of this one by z minus 1. At last I also written Lorentz series of a function about its singular point will be itself. Okay, now we are going to go for another question number 2, that is your find Lorentz series of 1 by z into z minus 1 about z0 equal to 1. Okay, so to solve this type of question, first we have to do the partial fraction of this question, then we are going to solve it. Okay, so first we are going to do the partial fraction of this question. Solution here starts. Given function is your given function fz equal to 1 by z into z minus 1, for which we have to find out Lorentz series about z0 equal to 1. Okay, now okay, for this function, what are the singular points? First we have to write. Okay, for this function, for this given function, okay, for this function the singular points are here this one, z equal to 0 and z equal to 1. Z equal to 0 one singular point and z equal to 1 is another singular point, because if I will be put 1 over here, then the denominator will be 0 and function could not be determined. That means value will be infinite. If just put z equal to 0 also, function will be indeterminate. So z equal to 0 and 1 are the two singular points of this function. But as per the question, we have to find out Lorentz series about z0 equal to 1. Okay, see here I am doing this question step by step. I suggest that you just do it step by step. Whenever you are going to practice, then you can omit your steps. Okay, now so to do that one, to find out the Lorentz series of this one, we have to do the partial fraction. By partial fraction we get partial fraction of fz, we get what? That implies 1 by z into z minus 1 can be written as 1 by z minus 1 minus 1 by z. You just subtract these two terms. Here you can see, then what we can found, if I'll be subtract these two terms, we can found this one. Okay, here you can see this will be, take the LCM, it will be z into z minus 1 and this will be z minus 1. So numerator will be z minus z plus 1 by z into z minus 1, so 1 by z into z minus 1. So the partial fraction of this one 1 by z into z minus 1 will be this one. See, about the partial fraction in detail we have been discussed in our Taylor series expansion videos. You can refer there. Okay, now we have to find out what Lorentz series of this one and Lorentz series of this one about z0 equal to 1 separately. Then we are going to subtract both the terms or both the series. So first of all, we have to find out the Lorentz series of this term about z0 equal to 1. We have to put the heading. Okay, finding the Lorentz series. So you just write this is your equation number 1. So Lorentz series of this one about z0 equal to 1 means Lorentz series of this one 1 by z minus 1 about z0 equal to 1 minus Lorentz series of 1 by z about z0 equal to 1. So separately we have to find out the Lorentz series of this one about the z0 equal to 1. Then we are going to subtract. So first we have to find the Lorentz series of this 1 by z minus 1. Find the Lorentz series of 1 by z minus 1 about z0 equal to 1. Okay, z0 equal to 1. So here you can see, here we are trying to find out Lorentz series of this function about its singular point. Last class we have been discussed that whenever we are trying to find out Lorentz series of a function about its singular point, then finally we can found the Lorentz series will be itself. Same question we have been done here. This one Lorentz series of 1 by z minus 1 equal to z about z equal to same function, that is your 1 by z minus 1, that you have to remember. That means we are going to do the same procedure. I am not doing here all the steps, you just do it. I suggest that you just write it. Okay, you just write it. I'm leaving the space. That means Lorentz series of 1 by z minus 1 about z0 or z equal to 1, whatever I written, blah blah, you just write. Don't skip. So finally what we can found, see here also you have to draw the graph. Here also you have to draw the graph once again, don't forget. Okay, I have to draw this graph only, then other writings you have to write. Okay, I'm just drawing the graph only. So this is your 1 2 3 minus 1 minus 2 minus 3. Here this is the point where about that point we have to find out the, here z0 equal to 1, this is the singular point. So this singular point we want to exclude from our calculation. So for that we have to draw a small circle having the small radius, that is your C2. Then C1 can be any radius. C1 can be any radius. We can consider by considering this is the center. C1 can be any radius. Same thing whatever we discussed in our last class, same thing you just write down once again for your practice. So C1 will be this one, C1 will be this one. So in between C1 and C2, at all the points this function is to be analytic except this point z0 equal to 1. So you just write all the steps, don't skip one step, just write all the step and we can found the Lorentz series of 1 by z minus 1 will be equal to 1 by z minus 1. Here you just add it about, here about z0 equal to 1. Okay, about z0 equal to 1, just Lorentz series of this one about this one about z0 equal to 1 equal to 1 by z minus 1. Similarly you just write all the steps here, don't skip. Finally we can found Lorentz series of 1 by z minus 1 about z0 equal to 1 will be equal to 1 by z minus 1. Okay, so first part we have been finished. That means Lorentz series of this one about z0 equal to 1 we have been completed. Don't skip, you have to write here all the steps whatever written here. Okay, now we are going to go to find out the Lorentz series of 1 by z about z0 equal to 1. So same thing, we have to write the heading, find the Lorentz series Find the Lorentz series of 1 by z about z0 equal to 1. About z0 equal to 1. Okay, so I suggest that here I am going to do step by step, and many things I am going to discuss. Carefully you have to observe. Carefully you have to observe this question particularly. Okay, so 2-3 question if you are going to solve with all the step, then any question in the Lorentz series in future you can easily you can solve. Okay, any question. Now, so here first of all I told that any question belongs to Lorentz series, we have to draw the figure. Okay, we have to draw the figure. First we have to draw the complex plane. This is the complex plane, right? This is the complex plane, this is the real axis, and this is your imaginary axis. This is your imaginary axis. So this is your 1 1 2 3 4, this will -1 -2 -3, and this will be I 2i 3i 4i -i -2i -3i -5i. I suggest always draw the figure. तो फिगर का क्या महत्व है ना इस लॉरेंट सीरीज में, आगे तुमको पता चल जाएगा. तो फिगर हमेशा ड्रॉ करना सीखो एनी लॉरेंट सीरीज का क्वेश्चन में. चाहे तुम इन योर एग्जाम यू आर नॉट गोइंग टू ड्रॉ, दैट इज सेपरेट थिंग, बट अभी तुम्हारे नोट में सारे के सारे फिगर रहना चाहिए. ओके ओके, नाउ दिस इज द z इक्वल टू 0 वैल्यू. So where we have to find out the Lorentz series of this function? Here, z0. This is the z0 position, right? This is the z0 position. This is the z0 position. Clearly you have to write z0 equal to 1. So first here you can see that this z0 is not the singular point of this function. First I am going to write this z0 where we have to find out the Lorentz series of this function. That point is not the singular point. For this function, singular point is the z equal to 0. Here z equal to 0 is the singular point, but this point is not the singular point for this function. So same thing I have to write here. In this case z0 equal to 1 is not the s dot p, means singular point of the function 1 by z, but sp of 1 by z equal to where will be sp, but sp of 1 by z will be at, okay, will be at where your z equal to 0. Z equal to 0 is the singular point of 1 by z function, right? So here we have to find out the Lorentz series not in the singular point. Singular point में हमको यहाँ पे निकालना नहीं है, हमको और एक पॉइंट जो सिंगुलर पॉइंट है नहीं वहाँ पे अबाउट दैट पॉइंट वी हैव टू फाइंड आउट द Lorentz series. So we know that except singular point, if we are trying to find out the Lorentz series, that means indirectly we have to find out the Taylor series, remember. Okay, so here I have to write this point is your z0, which is the singular point. Clearly you have to write this is the singular point of this function. Okay, so these 2 points we found. Then now first we are going to solve this question by using Lorentz series method. That means exactly this method we have to use, and we are going to solve. As I told that if we are going to find out the Lorentz series of a function not in the singular point like this question, that means indirectly it has been asked that we have to find out the Taylor series of that function. So how to find the Taylor series about a function, that we have been discussed in our previous videos. In detail we have been discussed. In that way also we are going to solve. So here we are going to solve this question first by this method. Okay, then we are going to go with our previous method what we have been solved Taylor series at that time, okay, in our previous videos. So first we have to what we have to write step by step, we have to write for this question in this method. Okay. Okay, we know that this one Lorentz series of fz, ls of fz is what? Is your fz equal to f1z plus f2z, right? f1z plus f2z, and we have to find out the f1z, then f2z, then we have to add it. So here you can see that f1z is the integral to find out the considering outer circle. This one, considering the outer circle, we have to find out the f1z value, f1z. Okay, this integral we have to find out, may you remember. And considering inner circle, we have to find out f2z. Here at the time of Lorentz series we discussed. So here inner circle, why we have been considered? Because this point is the singular point. About this singular point we find out the Lorentz series. So only for that we consider this inner circle, and outer circle is for f1z and inner circle for your f2z, by considering your what? Cauchy's integral theorem, Cauchy's integral formula, right? For this case, carefully try to observe this case. This point where we are trying to find out the Lorentz series, this point is not the singular point. If it is so, then f2 का सवाल ही पैदा नहीं उठता है, सवाल ही नहीं उठता है f2 the c2 why we are going to consider. See, I'm going to show you here why we consider the c2 over here, because this is your singular point. So to exclude this point, we just consider this circle to exclude this point. But in this question, this point is not the singular point. So why we are going to exclude it? We are not going to exclude it. We are not going to exclude it. But for this function, singular point is seated over here at z equal 0. This is the singular point, right? Okay. Now, suppose this function, if I am going to consider, will be starts from here in all the way. In all the way, it will be move. If the function will be move in all the way, that means here you can see this is not the singular point of this function. That means at this point, this function is analytic. So here is the analytic, here is the analytic, here is the analytic. If it will spread along this way, but exactly at this point, it is not analytic. Here at this point, z equal to 0, this function is not going to be definable. So this is your so-called singular point. So if the function will be spread in all the way from this point where we intend to find out the Lorentz series, then the spreadness is going to stop with the radius of this one, because here it will interact, it's a singular point. Are you got it? This is most important concept, or you can say tricks, to solve this type of question. I'm going to zoom it for you carefully. You have to listen and observe. Here, this is the point about which we are trying to find out the Lorentz series, and as this point is not the singular point, so c2 का सवाल ही पैदा नहीं उठता है. c2 we are not going to consider, because c2 we consider to exclude that point, because this is the point, is the singular point. To exclude that point and applying Cauchy's integral formula, we just considered c2. But here this point, and the same thing we done for the 1 minus z question, 1 by 1 minus z question. For this question we done the same. This is the singular point. To exclude this singular point, we consider this one, 1 by 1 minus z केस में. मगर यहाँ पे ये जो पॉइंट है, ये इस फंक्शन का सिंगुलर पॉइंट है नहीं. सो अबाउट दिस पॉइंट, वेन एवर वी आर ट्राइंग टू फाइंड आउट, you just consider from here the function is spreading in all the way. In all the way it is spreading, but the spreadness is going to be stop here. The spreading will be stopped at its singular point. So this is the tricks you just remember. That means we have to consider this region to solve this question. This is one type of tricks you just consider. So from here, if the function is going to be spread, so it will be create this region. So this region or boundary is nothing but so called c1, right? c2 तो है नहीं. अगर c2 है नहीं, तो what we are going to find out? So for this case, you just write for this case, okay, for this case Clearly we have to write for this case. This is the important point. You just write as the note. Okay, note what for this case, for this type of case, or for this case you can write for this case we have to find out. Okay, we have to find out. See, these things no need to write in your exam, but should write in your note. We have to find out Lorentz series of the function about the point which is not most important, which is not its singular point, hence C2 is not to be considered, So अतएव f2z will be equal to 0. If C2 will be not there, so what will be the f2z? Because f2z is nothing but the the integral of the C2. Considering C2 here, you can see f2z means what? f2z means here, considering C2 integral, C2 है नहीं तो f2 कहाँ से आएगा? नहीं आएगा, तो f2 will be 0. See, whatever written in the note, you just put it in the box, because no need to write these things in the exam. This is just for you, that you have to understand. Okay, but you have to write in your note. Okay, so that implies Lorentz series of the function, that means 1 by z will be what? Only f1z. Okay, that implies Lorentz series of 1 by z will be equal to so-called f1z. Okay, so-called f1z, क्योंकि f2z अभी है नहीं. Now we are going to find out the f1z. Okay, so just put a small heading, finding f1z. So for the f1z we need the what? Circle C1. Already in the figure I drawn that one, right? So this is the C1 and this is the our figure. Here you can see, to finding the C1, what we done, remember last class what we done? That means you will be stand on the C1 and you have to move inside this circle. So here C2 to hai nahi, so you have to stand on the C1 and you have to move inside this region to any point. This one is the any arbitrary point z, so you have to move from the circumference of C1 to this point. That means what is the work is your out to in work. Okay, out to in work, right? So for finding the f1z, work is your out to in. Okay, systematically we have to write out to in. Now for out to in, what is the general formula? We have to write first. Out to in, general formula is this one. For out to in general, we have to write as your denominator of the function, or yes, the denominator of the function will be in the form of what? We have to write in this format: z dash minus z0, z dash minus z0 minus z minus z0. Now our work to identify which one is the z0 and which one is the z dash, then our work will be over. Okay, then our denominator of the given function 1 by z is the given function, the denominator is z. Now this z will be written in this format. Okay, so for this case, what is the z0 here? Just write here, z0 is nothing but about the point where we have to find out, about the point ls to be found, that is the z0. The value is how much given? It is given as 1. This is the z0 value. Now which one is the z dash? Z dash is the point from where you start to move towards any point inside the region. That means z dash always on the circumference of C1. Same thing I'm going to write. Z dash is the point is on the C1, or you can write, okay, leave it, just you write on the C1 always, and is the point on the C1, and from which we need to move towards any point z in the region, in the specified region, See, I am telling that you should not write these things in your exam. This is for you, for your note. Okay, so for this case, if it is so, for this case, okay, just write, for this case z dash will be what? Z dash will be this one here, the so-called singular point. Here you can see any point on the circumference. So which point is known for this question? The point on the circumference here, this is your z0. Is your 0 is on the circumference of this circle. So here z equal to 0 will be act as z dash. Got my point? Okay, so here z dash is your what? 0, which represents the singular point. Or here for this case z dash is your 0 that means the so-called singular point of this question, you can say like this. Okay, now ls of 1 by z will be equal to what we have to write? 1 by z dash minus z0 here, because there is no numerator is there, so only denominator z is there. So z we have to write as z dash minus z0 minus z z0. Z dash is your what? Z dash is your 0, minus z0 is your 1, minus z is your any arbitrary point, minus 1. So this will be equal to how much? This will be equal to 1 by minus 1 minus z minus 1. Now here one important point always you have to remember. Here I marked as the star. That means always this point you have to remember what is the point. I'm telling to you what is the point. The point is that after doing up to this much, you just check that the denominator what we have been designed as per the Lorentz series concept, that denominator is exactly matched with our given function or not. Okay, so here this point is matching the denominator. Point you have to remember, mate is matching the denominator. Matching the denominator. So here whatever we found, this denominator is exactly matched with this one. That means what we found, this function is exactly matched with our initial function or not. If it is not so, then we have to further modify this result to match this one. Okay, so here is it visible? No, matching the denominator, this one, matching the denominator, this point. This is the star mark, means this is the point. Always you have to remember matching the denominator after this much process. Here you can see how you are going to match, you just carefully you have to watch. See here, don't remove this bracket, you should not remove this bracket, keep this bracket, but in the rough you just calculate, is it matching or not. Here -1 is there, minus z minus 1 is there. Okay, so here -1 minus z, this will be +1. That means what we found minus z. That means 1 by minus z we found after doing this much. But our initial function is what? Initial function is 1 by z. Is it matched? It is not matched. So what we have to write here, we have to put minus. If I will put minus over here, you just think, you just watch that this will be equal to 1 by z. Now it is matched, now it has been matched. Okay, okay, then what we are going to do, then here you can see, that implies ls of 1 by z will be equal to this one, -1. Then second step, after doing this, second step is that whatever will be the first term, this one, that may be -1, -5, 5, whatever may be the first term, that you have to take common from these two terms, -1 and z minus 1. Got my point? Is the most important point, most important. First term you have to common. You don't open the bracket, only this first term you have to take common from these two terms. What we can found here, you can see, if I will take -1 common from these two terms, we can found 1 plus z minus 1, yes, 1 plus z minus 1. Here -1, here -1, taken -1 common. So here you can see numerator also 1 -1 got cancelled. Finally we found 1 by 1 plus z minus 1. Okay, 1 by 1 plus z minus 1, this much we found. Now another one step is there. What is the step? We know that here I am going to write, we know that expansion or Taylor series of 1 by 1 plus z 1 by 1 plus z about z equal to 0, or we can write ts of 1 by 1 plus, see, about z equal to 0 means z minus 0, we have to write z minus 0 will be equal to how much, that we know, summation over n is equal to 0 to infinity minus 1 to the power n z minus 0 to the power n, or we can write 1 by 1 plus z. So j 0 we can omit here. So Taylor series of 1 by 1 plus z about z0 equal to 0, right, is equal to how much, is equal to summation over n equal to 0 to infinity minus 1 to the power n z to the power n. So here, if about z equal to 0, a Taylor series is your -1 to the n z minus 0 to the power n. So about z equal to any point, what we can write for this case, what we can write, similarly Taylor series of 1 by 1 plus z about z equal to, suppose a, any point. So what will the value, it's Taylor series of 1 by 1 plus, see here 1 plus z is there, means z about z equal to a, means this will be z minus a, right, z minus a which will be equal to, that means Taylor series about z0 equal to a, we have to find out, will be equal to how much, summation over n equal to 0 to infinity minus 1 to the power n z minus a to the power n. This is the in general case. Okay, in general case. For our case z0, or about which point we have to find out, about which point, the point is 1, your 1. So in this case in this case, this one 1 by 1 plus z minus 1 will be, in this case, Lorentz series of 1 by z about z0 equal to 1, which will be equal to expansion of 1 by 1 plus z minus 1, 1 by 1 plus z minus 1. So 1 by 1 plus z minus a is nothing but this one. So here this expansion will be how much? Minus 1 to the n, z minus 1 to the n. So finally Lorentz series of 1 by z about z0 will be 1 equal to 1 will be how much? Summation over n equal to 0 to infinity minus 1 to the power n z minus 1 to the power n. See, these things already you know in detail. Again I done because for your practice, but because these things we done several times when we have been discussed the Taylor series. So here I written this much for your practice only. You just write in a note what I told, that you just do 1 or 2 question in detail, then after Lorentz series will be easy for you. Any question you can do easily. Okay, here finally the Lorentz series of given function whatever in the question will be how much? Will be how much? Lorentz series of 1 by z minus 1 and then Lorentz series of 1 by z, both are going to be subtract. Okay, so finally we have to write, finally Lorentz series of 1 by z into z minus 1 about z0 equal to 1 will be what? Will be what? That implies 1 by z minus 1 will be equal to, that is your 1 by z, what it has been, sorry, 1 by z minus 1 minus 1 by z. That means Lorentz series of this one, Lorentz series of this one about z equal to 1. So we have to write 1 by z minus z1 Lorentz series. Okay, Lorentz series बार बार लिखने की जरूरत नहीं है, no need to write once again. You just write 1 by z into z minus 1 about z equal to 1. Lorentz series we have to find out will be equal to Lorentz series of this one about z equal to z0 equal to 1 about z0 equal to 1 already we found. So Lorentz series of this one about z0 equal to 1 is how much? Itself z minus 1 minus Lorentz series of this one about z0 equal to 1 is nothing but how much? Summation over n equal to 0 to infinity minus 1 to the power n z minus 1 to the power n. So this is the final answer of the given question. Right? Okay, as I told that we have to do this question. We have to do this question 1 by z Lorentz series about z0 equal to 1 by this method, and another method that the so-called Taylor series we have to find out for this one, for this question particularly, because here we have to find out the Lorentz series not it's a singular point. That means it is asked indirectly that we have to find out the Taylor series. Okay, so same thing we have to write. So this is the method. This write up whatever I written, no need to write in your exam. This is for you, for your understanding. Keep it in your note. Now another method, here I'm writing, just watch another method. other method to find LS of 1 by z about z0 equal to 1, about z0 equal to 1. So first of all we have to write this one, that as per the question Lorentz series is to be found except its singular point. singular point. That is indirectly in the question it is asked, in the question it has been asked that we have to find out Taylor's series of this function about z0 equal to 1. So this is written for you that you have to remember. So here except singular point we have to find out, and indirectly question asked that we have to find out the Taylor series about z0 equal to 1. So what is the given question? Question is the 1 by z. We have to find out, that means Taylor series of 1 by z about z0 equal to 1. May you have been remembered how we have been evaluated the Taylor series. If you forgot, you go back the previous videos where we have been discussed the Taylor series. So there what we done, suppose this question is given that 1 by z is the question. How to find out the Taylor series? What we done at the time, you can see Taylor series of 1 by z at z0 equal to 1. First we have to do, wherever the z, there we have to write z minus 1. So here I written z minus 1. So if I'm going to do so, here you can just match. This is 1 by z, here 1 by z minus 1. So what I have to do with this denominator, then it will match with this one, original function, if I will add plus 1, right? So Taylor series of 1 by z about z0 equal to 1, which will be equal to the expansion of this 1 by 1 plus z minus 1. So what will the expansion of this one? That means expansion of 1 by 1 plus z minus 1. 1 by 1 plus z minus 1. That means if I will take common 1, then it will be itself 1 plus z minus 1. So here just now we have been discussed that if 1 by 1 plus z will be there, z0 equal to 0, then it will be this one. Z minus 1, if it will z minus a, means it will be like this one, 1 plus z minus a about z0 equal to a. So here about z0 equal to 1, that means expansion of this one 1 by 1 plus z minus a is nothing but your summation over n equal to 0 to infinite minus 1 to the n into z minus 1 to the power n. So this is the Taylor series of 1 by z0 equal to 1. So here within 2 and 3 steps we found it's a series, a required Lorentz series. You just remember that whenever we have to find out the Lorentz series of the function except it's a Taylor series, most important point, this one I put it over here, hashtag, except it's a singular point. Indirectly in the question it has been asked that we have to find out the Taylor series of this function about z0 equal to 1. Okay, so here we are going to stop our today's discussion. In our next class we are going to go for another question, that finding the Lorentz series of 1 by z minus 3 about z0 equal to 5. So this is the case that we have to find out the Lorentz series of this function, not about its singular point. Its singular point is your 3, but we have to find out the Lorentz series about z0 equal to 5. That means in this question we have to find out the Taylor series. That means question asks that indirectly it is asked that we have to find out the Taylor series of this function about z0 equal to 5. Okay. So in the next class we are going to discuss this question and some other questions. So thank you so much for watching this video. Thank you.